Okay, here's my project. Applied a coursework. So the coursework. This is section A where I review the application area, spam and filtering. So I select the spam and email filtering. So overview. This is the overview. So I've written the part A and yeah, the literature review, and here's the references. In part B, we examine the contrast of AI method. I mentioned here three AI method techniques. One is naive Bayes, and another one is SVM, support vector machine, and the third one is neural networks, RNN, or in deep learning. So and I showed a comparison here. So this is part, and this is part C, implementation, where I featured how we collect the data, how the data pre-processing, features extraction, and a diagram how my model is built. And then the source of data, I'd have taken the data from Kaggle, which has like 5,726 rows and 2 columns, and I describe all the uh, properties of the data and how we have to pre-processing data before make the model. And yeah, so I choose naive Bayes model. I also explained why I choose naive Bayes model here. And it's basically like easy to make it, and also my data is not real time. I take it from Kaggle, and this is very simple. And also imbalanced data. So for imbalanced data we have to choose naive Bayes model. I've explained the things why I choose that. Okay, and here we start with the implementation, and I'll demonstrate like how I choose like this model for my this coursework. Okay, so firstly we imported the python's necessary Python libraries for this machine learning. uh, so we imported Panda, NumPy, and Seaborn as a CNS, and we uploaded the data from my PC. So this is the path of the data file, and this is our data. So the first column is text, the email text, and the second is spam, which is like labeled by 1 or 0. 1 means it's not true, and 0 means it's ham email. Like 1 is spam and 0 means true. Okay, so we type df dot shape, where it says like 5,726 column and 2 rows, and we derive the spam value and the ham value. So we can see in among the 5,206 there is zero, like ham email is 4,358, and spam email 1,368. So we can see there is a huge imbalance on the data set. So the legitimate email number is much more than the spam one. Okay, then we run the code for if there any email is double, like duplicate, then we can check there is no double. Sorry, yeah, there is a double. So when we run this code, after that we initiate this code again, like spam value dot counts. So then we can see there is double in real email, like ham email, which is reduced the number 4,325 from 4,358, and the spam value remains same. Then we check also if is there any null value. We check with this code, so we can see there is no null value. And yeah, so we have to split this data to define the like to make the model. So the x, there is a x which is like the email subject. So this is the x axis, and so when we run the x axis, it will come like as an array here, and y is df dot spam values, which is like come to as a array 1D array. So x is dependent and y is always y is independent, because depending on X, Y will give the value is it ham or spam email. Okay, so for that we need one more libraries, which is sklearn import, to train the test split. So yeah, so here is xtrain and xtest, which is run to split the data set. And we need another function with count vectorizer, which like convert the data set to count vectorizer, and then we feed the xtrain data into that count vectorizer. So that's why we write cv dot count vectorizer and xtrain equal to cv dot feed transform into xtrain. Then we transform the xtrain to array. So when we run this one comes as an array, and we use the multinomial naive Bayes model to for my data set. So yeah, we imported the libraries here, and this is the model, the variable we declare here. And when we transform the like x test equal to cv dot transform, and which comes as an array here. And then after that we are running for my accuracy. How is my accuracy after imported this naive Bayes model? And we can, as we can see, the model score is like almost 99%, so which is like a good accuracy, as we can say. So though my data is imbalanced, that's why we need more justification on this accuracy. So that's why check we will check more methodology for this result. So we can call confusion matrix precision for and calculate recall and calculate f1 score spam. So that, like, this kind of method also tell us how perfect the model it is. So yeah, we will run this method as well for this, and we can see confusion, we can see the results on here when we run the model. Okay, and spam and filter model evaluation. After running the model, I'm just checking with my model, is it correctly like detect any spam or ham. So I just give a random to email here, and two random, when I declare two random email here, and then I also again have to feed to the count vectorizer. That's why I type cv dot transform dot email, and when I again type for the predict to this email, so then the first one, it counts as a 0, so which was like the legitimate email, like real email. And the second one is like fake email, like spam email, which is like lucrative email. We have updated our login credential policy, please confirm your account by logging into Google Docs. So this definitely, this is looks dodgy things. So yeah, so as I can see, my model can easily like rectify the correct one and the non-correct one. So yeah, this is part D, software testing. So I mentioned those method as well here, how we can evaluate our model. And also part E, evaluate the results. I also mentioned this result here, which I got from this here. Yeah, so, and I also mentioned the strength and limitations as well for my this model. And yeah, in conclusion, like the neighbors classifier performs excellently for spam filtering with accuracy 99%. So yeah, I think I will cover everything. I hope so I have covered everything here. So there is basically three techniques, three model I have discussed about. One is naive Bayes, SBM, and deep learning. And I also mentioned their techniques and everything, and why I choose naive Bayes. I also mentioned that. So I have a clear clarification here. Yeah, so yeah, that's it. Thank you.